tonight, we're going to do something strange. Not by leaving Earth on a spacecraft, but by turning around and diving straight into the moment you are living right now. Feel the chair under you. Notice the glow of the screen, the hum of a fan, a car going by, the quiet in your room. Quantum physics suggests this exact configuration of you, this tiny pocket of space and time, may have happened before. Everyday experience insists that cannot be true. Time in your life feels like a one-way mission. Launch at birth, fly through the planets of childhood, work and aging, and then disappear beyond the horizon. One trajectory, no do-overs. Yet when scientists write down the equations that govern the solar system, the atoms in your brain, and the quantum fields that fill space, something unsettling appears. The math does not care about your feeling of flow. It treats every event as if it already exists. Before we get started, imagine the most ambitious mission ever flown. Voyager left the inner solar system and crossed an invisible boundary into interstellar space. Tonight, we're going to attempt a similar crossing. But the boundary is stranger, the edge of what you think time is. On one side, the familiar story where moments come once and then are gone. On the other, a picture where every moment is fixed in a vast structure, where configurations recur, and where your life may be one branch among countless alternatives. No one expects that from physics. No one predicts that the same equations used to calculate the solar wind or the orbit of planets would whisper that you might have already been here watching this in another pass through reality. Yet quantum indeterminacy, the wave function and the way outcomes collapse when observed, all chip away at the idea of a single linear timeline. In some views, all possible paths exist at once. In others, the universe evolves so deterministically that given enough time, states repeat. Relativity then adds another shock. In the block universe picture, spacetime is a four-dimensional landscape, with past, present, and future laid out like cities on a map. Your birth, this moment, and your death all coexist in that structure, as real as the planets orbiting the sun. From that perspective, you do not move through time. You reoccupy a fixed location in a cosmic architecture that does not flow. And beyond that, there are recurrence theorems hinting that a finite system can, after inconceivably long periods, return arbitrarily close to a previous state, and many worlds branching where every quantum event spawns parallel histories. Together, they raise a disturbing possibility. Perhaps you have already lived this moment in another branch, another cycle, another slice of the block. By the end of tonight, you're going to understand at least 3 rigorous scientific senses in which that could be true, and why that does not reduce your existence to a meaningless loop, but instead reframes what it means to live a single, irreplaceable now. Now, let's begin. So here is the mystery. Everyday experience says time is simple. It feels like a river flowing from past to future. Behind you, memories fixed and solid like planets already visited. Ahead of you, possibilities branching like trajectories a spacecraft might take through the solar system. Each second appears once, then disappears beyond the boundary of the past, never to be discovered again. That intuitive picture is so strong that it feels non-negotiable. You wake up, clocks tick, causes lead to effects, and the mission of your life seems to unfold frame by frame. The present feels like the leading edge of a wave, the only place that is truly real, while the past is recorded and the future is still under construction. No one expects this to be controversial, but the equations that scientists actually use to describe reality tell a very different story. In both relativity and quantum mechanics, the math does not care about past versus future the way you do. The fundamental laws are almost perfectly time-symmetric. Run them forward, you get a valid history. Run them backward, you get another valid history. From the perspective of the equations, there is no obvious arrow, no highlighted now, no preferred direction. Relativity goes further. It welds space and time into a single four-dimensional system, spacetime. In a spacetime diagram, your entire life is not a moving dot, but a long, static world line, stretching from birth to death. Past, present, and future events all coexist in this frozen geometric structure. The flowing river becomes a frozen landscape. The present is not a moving boundary in the universe, it is a moving boundary in consciousness. Quantum theory then takes that already uncomfortable picture and turns the dial beyond what absolutely no one anticipates. The wave function evolves smoothly and deterministically, like a vast, invisible solar wind blowing through the space of possibilities. Yet when observed, it appears to collapse into a single outcome. Cause and effect blur in experiments where choices made now seem to influence how particles behaved in the past. No one predicts that, but the data keep pointing there. So a set of questions emerges, sharp and unavoidable. Is the present objectively special, or just the point where your awareness is currently focused along a pre-existing world line? In a finite universe obeying quantum rules, could the overall microstate recur, recreating this exact experience down to the pattern of neurons firing as you listen? If quantum branching is real, are there countless near-identical copies of you in neighboring realities where this moment is almost, but not quite, the same? Before we get started on answers, notice the parallel. Voyager crossed what was supposed to be a clean edge of the solar system and instead found a messy, layered, shifting boundary that forced a rewrite of the mission playbook. Tonight, we're going to see that quantum physics does something similar to your sense of time. It reveals that the neat edge between past, present, and future is an illusion. To navigate this, 7 big ideas will serve as our map: indeterminacy, wave functions, and observers, block time and recurrence, many worlds and quantum consciousness speculations. By the end of tonight, you're going to understand how these pieces fit together into a single, unsettling claim, that this moment may not be as unique or as singularly yours as it feels. And the real shock comes when we ask what that means for free will in the quantum universe. And if that still has you here listening, that already says something important about you. Most people tap out the moment words like wave function and block universe hit the screen. You stayed. That means you're the kind of person who refuses the easy version of reality, who wants to understand the deep machinery behind time, space, and why this particular second feels like it belongs to you. Tonight, we're going to treat that curiosity as a mission trait. Think of this channel as a long-duration spacecraft, running on patience and questions instead of plutonium. Each video is a trajectory correction burn, nudging understanding a little farther beyond the familiar planets of pop science and into the darker regions where quantum indeterminacy, recurrence, and consciousness all start to blur together. Before we get started on the next leg of that journey, there is one small maneuver to ask from you. Pause, just for a heartbeat, and tap like or subscribe. Not as a ritual, as navigation. On this platform, engagement is the solar wind that decides which missions get pushed outward and which fall back into obscurity. When you respond, the algorithm reads that as a signal that long-form explorations of quantum time are worth sending beyond the usual boundary of quick clips and shallow takes. No one expects the recommendation system to care about wave functions. No one predicts that a single click from you can tilt the trajectory of weather topics like quantum recurrence, Poincare cycles, and block time rise into wider view. Yet, that is exactly what has been discovered in the data. Videos that hold the attention of a small, focused crew of explorers begin to surface for more viewers who feel that same pull toward the deep questions. Think of it this way. In a sea of short, bright distractions, detailed discussions of whether the universe loops are like tiny Voyager-class spacecraft, fragile, underpowered, but persistent. Without a push from viewers who actually care about the solar system, about the quantum rules beneath it, about what lies beyond our ordinary sense of time, those missions never reach interstellar space in the algorithmic sense. They never cross the heliopause into a broader audience. Pattern interrupt. This is not about channel growth for its own sake. It is about whether complex ideas get a chance to exist in public at all. Every like, every comment, every share is a small course correction that tells the system there is still a culture that values thinking hard about reality. Now that we're all on board the same ship, let's rewind the tape of physics and see how we ended up questioning whether this moment is unique at all. Rewinding the tape of physics means rewinding our picture of time itself. Tonight, we're going to step back before quantum weirdness, before multiverses, to a universe that felt solid, predictable, and comfortingly clockwork. In the classical world of Newton, time is a universal metronome. It ticks the same in every corner of space, indifferent to planets, motion, or anything that happens inside the solar system. 1 second on Earth is 1 second on Jupiter, 1 second on a distant spacecraft, 1 second for every observer, always. There is a single cosmic now, sweeping forward like a perfectly synchronized wave. That view is powerful. It lets scientists treat time as an invisible grid line, past behind, future ahead, the present as a razor-thin boundary sliding forward. By the end of tonight, you're going to understand why that comfortable picture had to be abandoned. But for centuries, it worked. Planetary orbits, falling apples, the entire mission of classical physics rested on this absolute clock. Then Einstein arrives, and the clock cracks. Special relativity fuses space and time into a single four-dimensional spacetime. Distances in space and durations in time stop being independent quantities. They blend into one fabric, warped not just by gravity, but reshaped by motion itself. No one predicts how radical this will be for the meaning of now. In relativity, simultaneity is not universal. Two events that are now for you may not be now for someone else moving differently through space. Picture this. One observer stands on Earth, another rushes past in a fast spacecraft, skimming the boundary of the solar wind. They pass each other and synchronize watches at that instant. Later, each marks which distant supernova explosion they consider to be happening right now. The calculations show they disagree. Not about the explosions, about the very slice of space-time they call the present. This is the pattern interrupt. The idea of a single global present, a shared cosmic moment, dissolves. Time is no longer a river with one surface. It is a direction in a four-dimensional landscape, and different observers carve out different nows through that landscape depending on their motion. From here, a new picture emerges almost reluctantly, the block universe. Imagine all events, every heartbeat, every solar flare, every future mission launch laid out in a static four-dimensional structure. Past, present, and future are all equally real, like different locations in space. No one expects consciousness to be roaming through a frozen cosmic library, but that is what the equations suggest. From a God's eye view, nothing truly comes into existence or slips away. Events simply are, etched into spacetime. Your birth, this exact moment, and your last breath all coexist in that block. Absolutely no one anticipates the emotional weight of that claim, because if the block universe is right, then every moment of your life is permanently inscribed, waiting, not to happen, but to be visited by whatever awareness is moving through this four-dimensional record next. In a block universe, nothing is waiting to be written. It is already there. Every joy, every mistake, every quiet, forgettable Tuesday, fixed in the geometry of space-time the way mountains are fixed in a landscape. Tonight, we're going to trade the comforting river of time picture for something stranger and much less forgiving. Before we get started, imagine holding a reel of film from an old projector. All the frames of the movie are physically present on that strip at once. The first scene, the final scene, the twist in the middle, side by side in space. Nothing on the reel is in the future of anything else. The illusion of a story unfolding only appears when the projector's light scans along the reel, frame by frame, at 24 images per second. Now, let's begin. Take that film reel and stretch it into 4 dimensions. In relativity, space-time is not a flowing river. It is a static block. Your entire life is etched into that block the way every frame is etched into the film. Your birth, this exact moment as you listen, and your death are not moving toward you. They already exist as distinct coordinates in the cosmic reel of the solar system, the galaxy, and the wider space beyond. From this perspective, time does not flow. There is no universal clock sweeping the universe forward. Instead, consciousness acts like the projector's light. It traces a path through this 4-dimensional landscape, lighting up one frame, then the next, creating the feeling of a moving now. Designed for a single linear mission from cradle to grave, your awareness behaves like a spacecraft flying a very specific trajectory through a pre-existing terrain. No one expects the emotional consequence of that picture. Because if every frame already exists, then in a deep, structural sense, you are always living every moment of your life. Right now, the version of you taking a first breath is still there in the block. The version of you watching a sunset decades from now is also there. The fact that you only feel one slice at a time does not erase the others. It only means the projector is not shining on them. By the end of tonight, you're going to understand why that matters for the idea of reliving moments. In a block universe, earlier and later are just directions, the way north and south are directions across a map. Move differently through the map, and you encounter the same town again. Move differently through a space-time, at least in principle, and you could encounter the same configuration of atoms, the same conversation, the same heartbeat. Here is the unsettling question. If all those frames are permanently present, is your sense that this is the first time you have lived this moment a deep truth about reality, or just a limitation of memory in a system that never sees the whole real at once? Absolutely no one anticipates what quantum physics will say when that question is pushed to its breaking point. So pause for a moment, not the video, your idea of time. Before we get started with more equations and exotic physics, run a quick experiment in the space behind your eyes. Imagine that time is not a river flowing past you, but a frozen sculpture, a vast, crystalline block. every moment of your life, every position of every particle in the solar system, carved into a single, unmoving structure. In that sculpture, nothing moves. Not the planets, not the galaxies, not even the flicker of a thought. The only thing that seems to move is your point of awareness. Think of it as an awareness cursor sliding along a track in that four-dimensional block. When it rests on one slice, that slice feels like now. Shift it, and a different slice lights up as present. Now, let's begin. Take that cursor and drag it backward. Not with your body, just with attention. A childhood room, a particular window, the way the light came in on a winter afternoon, the sound of a distant car or wind in the trees. Notice how the brain can rebuild that entire scene on demand. The world around you does not have to change. The physical spacecraft of your body stays in the chair, but awareness has jumped to a different coordinate in the sculpture. Then push the cursor forward. Imagine an interview next year, a journey to another country, standing under a dark sky, looking up at space, trying to understand if this life has a boundary or loops back on itself. Again, the external world has not moved. Only the simulation running in neural circuits has shifted, yet it feels like traveling through time. Here is the pattern interrupt. What if physics is telling you that reality itself works like that, not just your memory? In Einstein's relativity, the equations do not include a built-in flow of time. They describe a four-dimensional spacetime where past, present, and future all coexist, like pages already printed in a cosmic book. Many scientists call this the block universe. And the strange part is, the math works. By the end of tonight, you're going to understand that nothing in those equations demands a universal now that sweeps forward. So when experience reports that time is moving, another reading is possible. The universe could be a fixed structure, and what feels like motion is your consciousness scanning across it, the awareness cursor sliding from one frame to the next. Designed expectation. A single, fragile present being created in real time. Emerging reality. A landscape of moments, all equally real, with awareness tracing a path through them. If time is a landscape, then already lived stops being mystical and becomes geographic. It depends on where you are in that terrain and whether the path of awareness can curve, fold, or intersect itself. Tonight, we're going to push that idea further and ask a harder question. In a quantum universe, are there routes through this block that bring you back to the same point again and again? In relativity, time turns into a dimension. In quantum mechanics, reality itself turns into a question. What you think of as a single, solid world becomes a shimmering cloud of maybes, and your current moment is just one thin slice carved out of that haze. Before we get started, take the most ordinary scene you can imagine. You, watching this, neurons firing, photons from the screen hitting your eyes. In classical physics, every particle in that scene has a definite position and velocity at every instant. In quantum physics, that certainty evaporates. Particles are not tiny billiard balls. They are described by a wave function, a mathematical object that spreads out through space like a probability fog, assigning a weight to every possible place each particle could be. The wave function is the mission control of quantum reality. It encodes all the ways a system could turn out, all at once, and it does not jump around chaotically. It evolves smoothly according to a precise law called the Schrödinger equation. Given the wave function now, scientists can calculate the wave function later, just as predictably as tracking a spacecraft through the solar system. No one expects this part to be mysterious. It is clean, reversible, almost classical in its calm. The mystery arrives when a measurement happens. To see how violent that transition is, imagine the classic double-slit experiment. Fire a single electron toward a barrier with two narrow openings and a screen beyond. You might expect the electron to go through one slit or the other and hit one point on the screen, the way a grain of sand would. That is the expectation. Reality is stranger. Let the electron travel with no observation of which slit it uses, and the wave function does something radical. It passes through both slits at once, spreads through space, and interferes with itself like a water wave. After many electrons, the screen shows an interference pattern, bright and dark bands where the probability waves add or cancel. Each impact is a single dot. The overall pattern is the fingerprint of a wave spread out beyond anything classical. Now perform the same experiment, but place detectors at the slits to check which path the electron takes. Suddenly, the interference pattern vanishes. The elegant wave of possibilities collapses into a set of discrete hits, as if the electron had always chosen one slit. The smooth, deterministic evolution of the wave function is replaced in an instant by a single, seemingly random outcome. Here is the tension at the heart of quantum theory. Between measurements, the wave function flows like a perfectly reversible movie of the system. At measurement, it snaps into one frame, one definite result, and the other frames appear to vanish. No one predicts such a split personality from the equations alone, and absolutely no one anticipates how far interpretations will go to explain it. Many worlds takes the radical step. The wave function never really collapses. Every possible outcome continues in a branching cosmic archive, with the universe splitting into parallel histories. In that view, your present experience is one realized branch of an unimaginably vast quantum tree. The firing of each neuron in your brain, the exact pattern of electrical activity that makes this moment feel like now, corresponds to one path through that tree, while countless other near-identical versions unfold beyond your awareness. By the end of tonight, you're going to understand why this matters for the question of repetition. If quantum reality holds not just one timeline, but a superposition of many, then the idea that you have already lived this instant gains a new meaning. It is no longer just a poetic metaphor in a static block universe. It becomes a precise question about what happens to all the unrealized branches that could have contained you, and whether, over vast stretches of time and configuration space, the same conscious pattern can recur. Now, let's begin to follow that question into the next layer. What it means for a quantum system, perhaps even a conscious one, to revisit the same state, not just once, but over and over. Now, let's begin to follow that question into the machinery that makes a moment feel unique in the first place. In quantum mechanics, observation sounds mystical, but to physicists, it has a very precise meaning. It is any interaction that irreversibly entangles a system with something else. A photon bouncing off an atom, an electron hitting a detector, a molecule in your eye absorbing light from a distant star. No consciousness required. Once the system's delicate quantum superposition leaks into the wider environment, the options that could still interfere with each other are suddenly pinned to a shared fate. This is where decoherence enters. The environment is not passive background space. It is an active, relentless measuring device. Air molecules, thermal radiation, the solar wind of stray particles flying through the room, all of them are constantly bumping into quantum systems, entangling with them, and shredding superpositions into branches that can no longer talk to each other. At the scale of atoms, interference is visible. At the scale of you, it is drowned in a roar of environmental noise. The result is dramatic. A world that, in principle, is described by a smooth, wavering wave function across countless possibilities ends up looking like a classical solar system of definite planets, definite trajectories, definite outcomes. Decoherence turns quantum haze into the crisp, everyday reality your senses report. By the end of tonight, you're going to understand that this transition is not a clean boundary in space, but a gradual loss of access to alternatives that still exist in the underlying description. The traditional Copenhagen-style story adds one more ingredient. The wave function, it says, evolves smoothly according to the Schrödinger equation until a measurement happens. Then, in an instant, it collapses into a single outcome. One detector clicks, one path is taken, one history is written. From your perspective, this is why there seems to be only one past, one timeline, one chain of events that carried you from childhood to this exact moment. But there is a problem. Collapse is not in the Schrödinger equation. It is an extra rule bolted on. No one expects a fundamental law of nature to need a special exception for when someone looks. No one predicts a clean answer to what exactly counts as an observer, or why one outcome is chosen while all the others are discarded. Decoherence softens the blow by saying collapse is just an effective story. From inside one entangled branch, the others are inaccessible, so it feels as though they vanished. Yet, in the deeper quantum description, the full wave function still evolves, still carries all the unrealized possibilities, like hidden routes in a navigation system you did not select. If that is true, then your sense of a single, unique past is less like a fundamental feature of the universe and more like the limited view from one spacecraft following one trajectory through a much larger mission plan. Tonight, we're going to ask a disturbing question. If the other branches never truly go away, what does it mean to say this moment has not already happened again and again in parallel histories you can almost, but not quite, touch? To go deeper, the mission has to get stranger. The most radical way to rescue quantum theory from that mysterious collapse is to say it never happens. The wave function never jumps. It just keeps evolving smoothly, like the solar wind flowing endlessly through space. This is the many worlds interpretation. In this view, the equations are taken at face value. No hidden boundary where physics changes its rules. No special exception when an observer looks. Every possible outcome allowed by the wave function actually occurs, but in different branches of a larger, universal system that includes you, the planets, and every spacecraft ever launched. Now, let's begin to picture what that means. Think of each quantum event as a tiny decision point. An electron goes left or right, a photon hits a detector or passes through, a neuron in your brain fires or stays quiet. In standard stories, the universe chooses one option and discards the rest. In many worlds, nothing is discarded. The universal wave function stretches, splits, and branches with each alternative outcome realized in its own thread of reality. From inside one branch, there is no drama. Observers in that branch experience a single, clean history. A coin is flipped, and it lands heads. That is the only outcome they ever see. But from a God's eye view, the full picture is different. The wave function contains a branch where the coin lands tails as well, with a version of you watching that outcome, convinced it was the only one that ever happened. Now, apply that to this exact moment. In some branches, you never found this channel. In others, the recommendation appeared, but you scrolled past without a second thought. In a thin, eerie subset of branches, you are sitting in almost exactly this position, with almost exactly this expression, listening to almost exactly these words about the solar system, quantum theory, and the strange boundary between them. These are not sci-fi duplicates cruising around in parallel space, waiting to shake hands. They are non-communicating branches of a single enormous wave function. No signal crosses between them. No Voyager can hop the gap. From within each branch, the others are forever out of reach. But from that higher, mathematical perspective, they coexist, laid out side by side, like alternate trajectories in a mission design lab. Before we get started on what that means for time, pause on the disturbing implication. If many worlds is right, there is not just one you inhabiting this moment. There is a vast ensemble of nearly identical yous, each riding a slightly different branch, each absolutely certain this is the first and only time these thoughts have appeared. By the end of tonight, you're going to understand why some physicists suspect that feeling may be an illusion and why the true structure of time could be far more unsettling than a simple branching tree. So, here is the uncomfortable question. If there is this vast forest of branches, each one containing a version of you living this moment for the first time, can any of those branches ever meet again? In standard many worlds, the answer is supposed to be no. Once branches decohere, once the quantum phases get scrambled by interaction with the environment, they behave like separate, non-communicating histories. The interference patterns that once allowed them to overlap get washed out. For all practical purposes, they are gone from each other's view, but for all practical purposes is not the same as absolutely impossible. The equations never quite slam the door. The universal wave function still evolves smoothly and deterministically, according to the Schrödinger equation. It does not jump. It does not forget. It glides through an abstract mathematical arena called Hilbert space, the space of all possible quantum states. Tonight, we're going to treat that space the way scientists treat physical space in a solar system mission, something you can navigate, chart, and get lost in. Hilbert space is unimaginably high-dimensional, but it is not chaotic nonsense. The wave function traces a path through it, a trajectory shaped by the Hamiltonian, the energy rules of the universe. Now, let's begin to push that picture. If the wave function is following a path through this structured space, could that path ever loop back? Could it pass arbitrarily close to a previous configuration, so close that at a macroscopic level the planets, the spacecraft, the buildings, and your nervous system reassemble into something indistinguishable from right now? No one predicts that lightly. The number of microscopic arrangements compatible with your current scene is astronomically large. The boundary between exactly this and almost this is razor thin. Yet, in a finite region of Hilbert space, with a finite amount of energy, there is a mathematical temptation. Trajectories in a bounded space have a habit of wandering near where they have been before. And that brings the conversation uncomfortably close to an everyday, very human glitch in your mental timeline. Déjà vu. That eerie sense that a conversation, a street corner, a fragment of wind and traffic noise has already happened. By the end of tonight, you're going to understand at least 3 radically different ways physics can flirt with that feeling. Branches that nearly realign, quantum states that recur, cosmic cycles that drag the entire system back through familiar patterns. No one expects a passing brain sensation to have cousins in deep mathematical theorems and cosmological models. No one anticipates that the same ideas used to predict the return of a solar system configuration could, in principle, hint at the return of a single, fragile moment in your life. Before we get started on those details, hold this cliffhanger in mind. If the wave function's path really can fold back on itself in Hilbert space, is déjà vu just a neurological misfire, or the faint echo of a universe that has been here before? So pause the déjà vu question for a second and step sideways into a different image. Tonight, we're going to walk into a library that should not exist, a library so vast it makes the entire observable universe feel like a single shelf. Now, let's begin. Imagine a finite region of space around you right now, your room, your street, the tiny bubble of the solar system you happen to occupy. Inside that region, every particle has a position and a momentum. Every neuron in your brain, every photon bouncing off the wall, every molecule in your lungs. Take that entire configuration and freeze it. That frozen pattern is one page in an unimaginably huge, but still finite, cosmic book. This is the cosmic library metaphor. Each page is one possible arrangement of particles in that region, down to whatever resolution the laws of physics allow. Most pages are gibberish, planets torn apart, brains scrambled, solar wind blasting through impossible geometries. But some pages are coherent. On a vanishingly thin set of pages, there is a conscious observer in a functioning body, in a stable planetary system, remembering a life. Your current moment is one of those pages, not just your memories, not just your emotions. The exact electrical pattern in your cortex, the faint hum of distant traffic, the precise angle of your head, the trajectory of a dust grain crossing a shaft of light, all of it together is a single, specific page in the library defined by the positions and momenta of particles within your local boundary of space. Now, perform a thought experiment. Imagine that, over vast timescales, the universe flips through these pages. Not like a reader with a purpose, but like a random walk in configuration space as the global wave function evolves and redistributes amplitude from one arrangement to another. Flip long enough, and the rules of probability say something uncomfortable. With enough time, the system will wander arbitrarily close to any chosen page, including the one that encodes this exact moment. Here is the pattern interrupt. This is not just poetic language about fate or destiny. It is a preview of a hard mathematical result. The Poinseret recurrence theorem tells scientists that for certain finite, isolated systems, the trajectory through state space does not just drift off forever. After a sufficiently long but finite time, it returns arbitrarily close to where it started. By the end of tonight, you're going to understand why that matters. Because if, at some deep level, the universe behaves like a bounded system with a finite library of pages, then recurrence is not a myth. No one expects a life to be a rereadable chapter. No one predicts that a consciousness could, in principle, reappear as the same configuration. And absolutely no one anticipates what it means if the book of reality is destined to fall open on your page again and again across eons. In the next section, that eerie library will stop being a metaphor and start looking like a theorem. That library of possible lives is not just poetic language. In classical mechanics, it turns into a razor-sharp statement. It has a name, the Poincare recurrence theorem. Tonight, we're going to let that theorem walk straight into your timeline. Now, let's begin. In plain language, the Poincare recurrence theorem says this: take a closed, finite system with fixed total energy, let it evolve long enough, and the system will, with mathematical certainty, return arbitrarily close to where it started, not in spirit, in configuration. The precise microstate, or something so close it is effectively indistinguishable at any macroscopic scale you could observe. There are conditions. They matter. The system has to conserve what physicists call phase space volume as it evolves, which is a fancy way of saying the possible states don't smear out or disappear. They just flow and rearrange. Its energy has to be bounded, so it cannot pump energy to infinity, and it has to be isolated from the outside. No external forces, no leaking heat, no cosmic wind blowing through. These are idealizations, yes, but they are the same kind of idealizations that let scientists navigate spacecraft across the solar system with absurd precision. To see how strange this is, imagine a simple box of gas, 1 trillion molecules bouncing, colliding, racing in all directions. At any instant, the gas has a specific microstate. Every molecule has a position and a velocity. That microstate almost never looks orderly. No one expects all the molecules to huddle in one corner. That would be like shuffling a deck and getting perfect order on the first try. But the theorem says something wild. If the box is perfectly sealed with fixed energy and you wait long enough, the molecules will, with probability 1, wander into a configuration arbitrarily close to any arrangement they have ever had. That includes the all-in-one-corner arrangement. That includes whatever configuration corresponds to you taking a breath, blinking, thinking this exact thought. If you could somehow encode your entire body and brain as moving particles in that box. Scale this up. If the universe, or at least a huge, finite region of it, acts like such an isolated system, then its total microstate drifts through a colossal phase space but never escapes it. Given enough time, the system does not just explore new configurations, it revisits old neighborhoods. It passes arbitrarily close to previous points. By the end of tonight, you're going to understand why that means your current macroscopic state, down to the pattern of neurons firing as you listen, is not privileged. It is a configuration among configurations, one that the equations quietly allow to reappear. The catch is the timescale. These recurrence times are not just long. They are beyond astronomical. Numbers with exponents that make the age of the solar system look microscopic. No one predicts a practical reset you could ever witness. But in mathematics, long is not the same as never. If the conditions hold, recurrence is not a possibility. It is a guarantee. And quantum theory takes this classical guarantee and threads it into the wave function itself, turning recurrence from a distant curiosity into something far more unsettling for your sense of a single linear life. So, what does that guarantee actually mean for you, sitting here watching this, feeling like this is the only time you will ever be this version of yourself? Now, let's begin. Translate the theorem into personal terms. If the universe's microscopic configuration ever comes arbitrarily close to what it is right now, then, in principle, there exists a future moment where a version of you appears again, with the same memories, the same worries, the same sense that this is now and everything else is before. From the inside, that recurrence would not feel like a rerun. It would just feel like your life. Arbitrarily close sounds technical, almost harmless. It is not. At the atomic level, there is no way for your neurons to keep a detailed log of which particular electron took which particular path through space. Change the position of a few atoms by a fraction of a proton's width, and your conscious experience does not suddenly glitch. For a human brain, an extremely close approximation of its microstate is effectively identical. The movie in your head plays the same frames. The thoughts follow the same track. So, in the right finite system, Poincare recurrence does not merely hint that something like you might come back. It says that, over a long enough mission through time, exact or near exact copies of this entire situation are guaranteed. No one expects a theorem about a box of gas to reach that far into personal identity. No one predicts that a line of equations could imply you might sit through the same argument, the same heartbreak, the same late-night video, again and again across aeons. But before we get started on declaring your life an endless loop, there are serious caveats. The original proof assumes a perfectly finite, isolated system. Our universe does not look like a neat laboratory box. Space is expanding. Gravity curves spacetime. Quantum fields fill the cosmos, fluctuating even in the darkest regions beyond the most distant galaxies. The solar wind that streams out from our sun never really stops. It just thins into the interstellar medium. Nothing is perfectly sealed. Many cosmologists argue that once dark energy takes over and expansion accelerates, distant regions drift forever beyond each other's horizon. In that picture, the global system may never recycle its exact configurations. Some models of quantum gravity and inflation even suggest an effectively infinite cosmos, where the simple counting argument behind recurrence breaks down. So the clean guarantee from the theorem collides with a messy, dynamic, perhaps unbounded reality. By the end of tonight, you're going to understand a subtle middle ground. The Poincare recurrence theorem cannot promise that your particular life will replay in our actual universe, but it does something almost as shocking. It proves that in any truly finite world with stable laws, exact or near-exact repeats of complex histories are not forbidden miracles. They are mathematically inevitable, given enough time. And quantum theory adds one final twist. It may not wait for the far future to mirror you. It might already be doing it right now in the invisible branches of the wave function you never see. Quantum theory's twist is not only about branching, it is also about returning. Tonight, we're going to watch a quantum state leave home, wander through its entire possibility space, and then, against every classical instinct, come back, looking almost exactly like it did at the start. Not in a mystical way, in a brutally precise mathematical way. Now let's begin. Imagine a simple quantum mission, a single particle trapped in a one-dimensional box, like a tiny spacecraft, confined between two perfectly reflecting walls. Its state is a wave function, a rippling pattern of probability spread across that box. At first, you prepare it as a compact wave packet, localized near one side. Then you let it go. Classically, a particle would just bounce back and forth, predictable and repetitive. Quantum mechanically, the wave function spreads. It interferes with itself. Peaks and valleys form, smear out, and form again. For a while it looks nothing like the tidy packet you started with. The boundary conditions of the box and the discrete energy levels allowed inside it drive a complicated choreography of overlapping waves. But here is the surprise. Because those energy levels are discrete, and their time evolution is governed by precise frequencies. The entire pattern does not wander off into randomness forever. After a sufficiently long but finite time, the wave function evolves into a shape arbitrarily close to its initial packet. The quantum mission returns to its launch configuration. This is quantum recurrence. It is the microscopic cousin of the Poincare recurrence you just saw in classical phase space. Their trajectories in a finite, bounded system must, given enough time, swing back near where they started. Here the same logic is encoded in the spectrum of the Hamiltonian. The allowed energies act like musical notes. Their frequencies beat against each other. Given long enough, their phases realign and the original melody of the wave function reappears. You can picture it, a bright lump of probability racing across the box, spreading into a delicate interference pattern, dissolving into something almost unrecognizable. Then, slowly, the chaos refocuses. The peaks line up. A familiar shape condenses out of the quantum haze, nearly the same as the one you prepared ages before. By the end of tonight, you're going to understand why this is not just a party trick of toy models. Every atom in your brain lives in a quantum world of discrete levels and boundary conditions. In principle, large quantum systems built from such components can also exhibit recurrences, returning to configurations that encode macroscopic patterns, a memory, a perception, the exact neural firing pattern that realizes the moment you are having right now. No one predicts that a warm, noisy brain will neatly rewind. Decoherence, environmental interactions, and the relentless wind of thermal motion smear out those delicate phase relationships almost instantly. For realistic systems, the recurrence times are so vast that they dwarf the age of the solar system. But the conceptual point is brutal and clear. The laws do not forbid the universe from revisiting configurations like this one. They quietly permit it. And once the laws permit it, a deeper question appears. In a quantum cosmos that can both branch and recur, what does it actually mean to say this moment is unique? To feel how strange that question really is, take a breath and picture something absurd. Not a galaxy, not a black hole, a monkey, one monkey, sitting at a typewriter in deep space. Tonight, we're going to hand that monkey an infinite amount of time. The infinite monkey theorem says that if a monkey hits keys at random for long enough, it will almost surely type any finite text you choose. The complete works of Shakespeare, every line of code ever written, the exact sequence of characters that encodes this sentence and the next one and the one after that. Given enough time, nothing that is allowed is truly off the table. Now, let's begin to shift that image. Replace the monkey with the universe. Replace the typewriter keys with all the microscopic configurations of matter and energy that the laws of physics permit. Instead of random letters, think of quantum states, positions of particles, fields, the solar wind streaming through space, the entire cosmic system wandering through its allowed possibilities. In this picture, your current moment is just one very specific arrangement of all those degrees of freedom. The pattern of photons entering your eyes, the electrical activity in your brain, the position of every atom in the room. In the language of the monkey, your life right now is a page of text the cosmos has typed. Here is the pattern interrupt. The universe is not a drunk monkey. Physical evolution is not pure randomness. It is guided by equations. The Schrödinger equation in quantum mechanics, Einstein's field equations in relativity, the dynamical rules that scientists use to understand everything from planets to particles. Sometimes those rules are deterministic, sometimes probabilistic, but they are never arbitrary. And yet, even under strict laws, a finite system with enough time can still explore its state space thoroughly. Just as a spacecraft can cross the boundary of the heliosphere and enter a new regime while still obeying every constraint of celestial mechanics, a quantum universe can roam through configuration space while never breaking its own rules. If the cosmos is large enough in time or in sheer spatial extent, the odds begin to look like that monkey's promise. At that scale, no one expects your particular sequence of experiences to be protected by cosmic copyright. No one predicts that this exact pattern of neurons, this exact line of thought, happens once and never again. If space extends far beyond the observable horizon, or if time stretches inconceivably far into the future, then copies of your life story may be as unavoidable as the monkey eventually producing Hamlet. By the end of tonight, you're going to understand that this does not automatically drain life of meaning. It does something subtler. It challenges the intuition that unique and valuable are the same word. The next step is to ask, in a quantum cosmos that can branch, recur, and repeat, what does it actually mean to be you, right here, on this particular run-through of the script? So far, the focus has been on time, on reruns of the same cosmic play. But there is another quieter possibility hiding in the equations. Tonight, we're going to slide the camera sideways and ask, what if this moment is repeating not in time, but across space? Cosmologists call one leading picture eternal inflation. In the earliest fraction of a second, space itself does not just expand, it balloons at an almost unimaginable rate. In many models, that runaway expansion never fully shuts off. Some regions cool and settle into something like our familiar solar system and its surrounding cosmos. Other regions keep inflating endlessly, spawning new bubble universes, the way boiling water spawns bubbles in a pot. No one expects these bubbles to be identical. Different bubbles can have different physical constants, different particle types, even different numbers of large dimensions. To an observer inside, each bubble feels like an entire universe, with its own history, its own planets, its own boundary between what can and cannot be seen. The mission becomes to understand not just one universe, but an inflating multiverse, a vast sea in which our observable region is a single droplet. But here is the twist. Even if there were no other bubbles at all, even if there were only one enormous universe with uniform laws, the stage would still be big enough for repetition. In such a universe, space can be effectively infinite. Scientists then talk about Hubble volumes or observable patches, regions like the one centered on Earth, limited by the speed of light and the age of the cosmos. Beyond that boundary, more space. Beyond that, more again. Inside each Hubble volume, there is only a finite amount of information, a finite number of particles, a finite range of energies, a finite set of ways to arrange them, even if that number is astronomically large. Combine that with an infinite or just ridiculously large expanse of nearly identical space, and a strange statistical wind starts to blow. By the end of tonight, you're going to understand why, in that scenario, exact duplicates stop being science fiction and start being almost mandatory. The argument is brutally simple. With finite possible configurations and effectively infinite tries, every allowed configuration appears not once, but over and over. Somewhere, in another Hubble volume, unimaginably far beyond any spacecraft, there is a region that matches ours particle for particle. Same galaxies, same solar system, same Earth, same you, down to the last neuron firing as you hear this sentence. This is not a time loop. This is not Poincare recurrence playing out over eons. This is spatial repetition. Right now in parallel, not in the future or the past. No one predicts being forced to share identity with a stranger trillions of light years away, yet the equations quietly point in that direction. If that is true, then this moment is not unique in the grand ensemble of reality. It is one tile in a mosaic of identical tiles scattered through an inflating cosmos. The next question is even more unsettling. If there are countless copies of you living this same instant, what exactly is it that singles out your experience as yours? One place to look for an answer is a feeling you already know. That eerie jolt when a moment unfolds and something in you whispers, "This has happened before." You walk into a room on the other side of the planet, the light through the window, the angle of a chair, a fragment of conversation about some distant space mission. All of it snaps together with an uncanny clarity. For a second, the present feels like a replay. Then it slips. You know with the rational part of your mind that this exact configuration of events in this solar system has never occurred. But the sensation lingers, as if reality just repeated a frame. Scientists studying the brain do not need nearby universes to explain this. The mainstream picture is surprisingly down to earth. Memory is not a perfect recording. It is a reconstruction. Neurons that store patterns of past experience can misfire, activating just out of sync with the sensory data streaming in right now. The result is a brief overlap where the machinery that tags an experience as present and the machinery that tags it as remembered light up together. In that view, déjà vu is a glitch in temporal processing. A tiny delay in one pathway, a pattern recognized twice. An echo in wetware, not a message from beyond the boundary of this universe. No one expects a simple, subjective feeling to overturn physics. But now, place that ordinary explanation next to the stories the equations are telling. Quantum mechanics describes your brain at any instant as one configuration in a vast space of possibilities. The same laws that govern atoms in interstellar space govern the ions flowing through your neurons. In principle, there are other times and, in some interpretations, other branches of reality, where those ions line up in almost exactly the same way. From that perspective, déjà vu starts to sound like resonance, not because any signal is literally crossing from one universe to another, but because nearly identical brain states can exist at different points in time or in nearby branches of a many worlds picture. The feeling that this moment has happened could be what it is like for a system to pass close to a configuration it has already occupied, or that its quantum cousins are occupying elsewhere. Before we get started on wild conclusions, a clear warning, there is no scientific evidence that déjà vu is quantum leakage between universes. None. The data support temporal glitches, memory quirks, and pattern matching errors. Yet the underlying physics does allow for near identical configurations of you to exist scattered through time and, in some models, spread across a branching cosmic wave function. Tonight, we're going to let those two stories sit side by side, the cautious narrative of neuroscience and the more poetic possibilities suggested by quantum theory. By the end of tonight, you're going to understand where current science truly ends and where imagination begins to drift beyond the solid ground of evidence. Now, let's begin to pull those boundaries apart. Those boundaries do not only exist out in space, they also run straight through time. And in quantum physics, the place where those lines blur most dramatically is in a family of experiments that no one expects to make sense on a first pass: delayed choice and quantum erasers. Before we get started, picture a classic double-slit experiment. A single photon leaves a source, heads toward a barrier with two slits, and then lands on a screen. When both slits are open and no one checks which slit it used, the pattern on the screen shows interference, as if each photon were a wave exploring both paths at once. When the experimental mission changes and detectors are placed to learn which slit it went through, the interference vanishes. The photon behaves like a tiny bullet. Now, here is the twist. In a delayed choice setup, the decision to measure which slit or interference is made after the photon has already passed the slits, but before it hits the final detector. Expectation: the photons passed should be fixed. Reality: the statistics on the screen line up as if the photon knew which measurement would be chosen. When scientists choose to preserve which path information, the data demand a particle-like history. When they choose an interference measurement, the data demand a wave-like history. It looks as though the future measurement reaches back and rewrites the past trajectory. No one predicts that from a simple, linear picture of time. Yet every time the experiment is run, the boundary between before and after bends. The description of what the photon must have been doing between the slits and the screen depends on a choice made later. The quantum eraser variant pushes this even further. Entangled photons are created. One heads toward a screen, the other toward a separate device that can either preserve or erase which path information. The strange part is that the decision to erase can be made after the first photon has already been detected. When the which path record is preserved, the combined data show no interference. When that information is deliberately erased, an interference pattern emerges in the correlations, as if a wave had gone through both slits. By the end of tonight, you're going to understand why most physicists insist this is not literal time travel. No usable information travels backward. No message is sent into yesterday. What changes is the way the entire experimental record has to be understood as one indivisible whole, stretching from preparation to measurement, from past to future. The lesson is brutal for common sense. The quantum world does not hand over a single, rigid, observer-independent history. Instead, history crystallizes only when the full measurement context is included, even if that context lies in what you call now or later. If the past of a single photon is that malleable, what does that say about the story of a whole brain, a whole life, a whole solar system of experiences you believe you've lived only once? Tonight, we're going to push that question to its breaking point. To push that question, you have to leave space for a moment and turn inward, not to anything mystical, but to the 3 pounds of neural tissue that are telling you this moment is happening now and that the last one is safely in the past. Before we get started on exotic universes, look at a quieter mystery: your own sense of time. Your brain does not sit there like a camera, recording a solar system of events in perfect order. It behaves more like a mission editor. It takes scattered signals, delayed transmissions from your senses, echoes from memory, and splices them into a smooth narrative of before, now, and after. By the end of tonight, you're going to understand that this timeline feels continuous, not because reality is simple, but because the editing is invisible. Consider a simple touch. Scientists can electrically stimulate the part of the brain that represents your hand, then, a moment later, actually touch your skin. You report feeling a single touch, not two. Even stranger, the brain can backdate that blended sensation so it feels like it happened at the time of the real contact. Expectation sensations arrive, then you feel them. Reality sensations arrive, get buffered for tens or hundreds of milliseconds, then are rearranged into a best-guess story. Vision does the same thing. A ball crosses your field of view. A sound happens a fraction of a second later. Your brain often pulls the sound backward in subjective time so it lines up with the visual event. No one predicts that awareness would lag behind like a slow spacecraft receiving telemetry, but experiment after experiment shows a consistent delay between raw neural processing and conscious experience. During that delay, the narrative is still fluid. Here's the pattern interrupt. What you call now is already old news by the time you feel it. The neural wind has already swept through. Signals have already crossed synaptic boundaries, and only then does consciousness light up the scene. Tonight, we're going to use that delay as a bridge between physics and phenomenology. In delayed choice experiments, the universe does not fix a single observer-independent history for a photon until the full measurement context is taken into account. In your brain, something parallel happens. The system does not fix a single unedited story of your personal timeline until after multiple candidate interpretations have been assembled, compared, and in some cases discarded. Expectation, one clean pass through time. Reality, multiple drafts. No one expects the comparison to go this far, but it does. Just as quantum measurements can retroactively decide whether a photon went through one path or two, your awareness can retroactively decide whether two events were separate or fused, earlier or later, cause or effect. The past of your experience is not simply remembered, it is reconstructed. That means the feeling that you have lived a moment once in a straight line may be more narrative convenience than physical fact. Your brain, like a careful team of scientists, is constantly revising its mission log. The question is, if the log can be rewritten, what does that say about whether this moment is truly unique or just one frame in a larger, repeating film you have yet to see? But what if that larger film is not just a metaphor? What if some scientists are genuinely asking whether the projector itself is quantum? Tonight, we're going to step out to the very edge of what can still be called science, into proposals where consciousness and quantum physics share the same mysterious boundary. Before we get started, it is crucial to plant a warning flag. This is not established terrain. This is the dim region beyond the well-mapped solar system of neuroscience, where speculative spacecraft venture and many never return. The ideas here are fascinating, dramatic, and often beautiful. They are also controversial, and most working scientists treat them with extreme caution. One of the most famous proposals is due to Roger Penrose and Stuart Hameroff. Their orchestrated objective reduction, or OR, suggests that quantum processes inside tiny structures called microtubules, inside neurons, might be tied directly to conscious experience. In this view, the brain is not just an electrochemical network, it is a quantum information processor, where superpositions collapse in special, gravity-linked ways that generate the feeling of a flowing now. Expectation, the brain as a warm, wet, classical machine. Reality, in this picture, a delicate quantum system humming beneath your everyday awareness. That contrast is powerful, but most neuroscientists and physicists remain deeply skeptical. Quantum coherence is fragile. In the warm, noisy environment of brain tissue, decoherence times are calculated to be unimaginably short, far shorter than the time scales of neuron firing or conscious perception. Think of a quantum state as a precise chord played in perfect unison. The brain is more like a turbulent wind tunnel than a quiet concert hall. Collisions, thermal motion, and constant molecular activity shred those chords almost instantly. For OR to work, the microtubules would have to shelter coherent quantum states for long periods across huge networks of cells. No one predicts that to be easy. Many argue it is nearly impossible. Around this, other speculative ideas orbit. Some suggest that consciousness causes the collapse of the wave function, that the universe remains in a haze of possibilities until a mind looks and snaps reality into a single outcome. Others push further, toward panpsychism, the idea that consciousness, in some primitive form, is a fundamental aspect of the universe, perhaps woven into quantum information itself, present from the smallest particles to the largest systems. By the end of tonight, you're going to understand why these ideas are so seductive. They seem to promise a bridge between subjective experience and the hard equations of quantum theory. But there is a problem. Many of these proposals lack clear, testable predictions that would let spacecraft of data distinguish them from standard models of the brain. They explain everything. They predict almost nothing. So where does that leave the question of whether this moment has already been lived? Even without quantum consciousness, quantum physics still shapes how your neurons fire, how signals race through your nervous system, how the brain slices continuous processes into discrete frames of awareness. The mission from here is to separate rigorous results from poetic speculation and to ask, in a universe governed by quantum laws, what does it really mean for a moment to repeat? Now, let's begin. If quantum physics lets time loop, branch, or freeze into a block, the next question is uncomfortable. Who, exactly, is looping? If this moment can exist in many places in the grand structure of the universe, are you the same you in all of them? Before we get started, notice how the old picture quietly smuggles in an answer. One timeline, one body, one continuous thread of experience moving through the solar system of your life. Disrupt that thread, and identity feels broken. But in a block universe, the entire thread already exists at once. Every thought and heartbeat laid out like a completed space mission report. You do not travel along it. You are the whole line. From that perspective, the you at age 7 and the you watching this are just different coordinates in space-time, like two planets in the same system. What links them is not some invisible soul crossing a boundary, but psychological continuity, memories, personality, and brain structure forming a chain of overlapping similarities. Scientists studying the brain already lean on this view. Neurons die and are replaced. Atoms flow through you like a biological solar wind. Yet the pattern persists. Now connect this to recurrence. In a finite quantum system, the Poincaré theorem says that, given enough time, configurations can return arbitrarily close to where they started. If, eons from now, the universe or some region of it reassembles a brain whose microscopic state matches yours right now, many philosophers would say that observer is as much you as you are. Same memories, same fears, same half-remembered dream from last night. Designed for one brief mission, the pattern launches again. This is where expectation collides with reality. Expectation identity needs an unbroken, unique timeline. Reality, physics only promises repeating patterns in a vast configuration space. No one predicts that comfort. No one expects recurrence to care about your feeling of being a single, irreplaceable thread. Many worlds turns the dial further. Every quantum measurement, every scattered photon branches the wave function. Each branch contains a version of you with its own continuous history, its own unbroken psychological chain. From the inside, each one feels like the only one. From the outside, they are near-identical spacecraft launched from the same pad, diverging as tiny differences in quantum weather accumulate over time. Tonight, we're going to treat identity less like a serial number and more like a mission profile. On this view, you are a pattern that can be instantiated in many places, times, and branches, not a single tape that can only be played once. By the end of tonight, you're going to understand why that idea is both unsettling and strangely liberating. Because if the universe is a block, and quantum theory allows endless branching and recurrence beyond any boundary you imagine, then the real puzzle is not whether this moment has happened before. The real puzzle is, why does it feel like there's only one of you here to experience it, and what happens to that feeling when the equations say otherwise? So, here's the twist. That lonely feeling of being the only one here right now might be a perceptual illusion riding on top of three very different physical stories about time. Tonight, we're going to sharpen that puzzle by laying out three concrete ways this moment might not be unique at all. Three mechanisms drawn from mainstream physics, not fringe mysticism. Three routes by which you could have been here before, even if your memory insists this is the first pass. Mechanism 1 is the block universe from relativity. In Einstein's picture, space and time fuse into a single four-dimensional spacetime, a static geometric object where every event simply is. Your birth, this sentence, your death, all laid out like cities on a map. From inside the map, you feel a solar day flowing, one moment replacing the last. But from the outside, nothing flows. The entire mission is already there. In that sense, you are always living this moment because the slice of space-time that contains you reading this never vanishes. It doesn't recur in time, it just eternally exists as one region in the larger structure. Mechanism 2 is recurrence. Here time does move, but configurations can come back. In classical mechanics, the Poinseret recurrence theorem says that a finite, isolated system evolving under deterministic laws will, after an unimaginably long interval, return arbitrarily close to a previous state. The same solar wind patterns, the same arrangements of atoms, the same neural firing in your brain. Quantum mechanics has its own flavors of recurrence, where a finite quantum system's wave function can evolve back near its starting point. No one predicts your exact life will loop every Tuesday, but over absurdly long timescales, the equations allow worlds that echo themselves again and again, beyond any boundary you normally imagine for a human lifetime. Mechanism 3 is multiplicity. The many worlds interpretation of quantum mechanics removes wave function, collapse, and says every allowed outcome happens, each in its own branch of the universal wave function. Every time a quantum event could go multiple ways. The global state of the system branches. That means there are branches where every detail of this moment matches what you're experiencing down to the last photon. Cosmology adds another layer. In some inflationary models, space is so vast that distant regions repeat configurations, creating true cosmic duplicates of you and your surroundings far beyond our observable solar system. Not metaphorical copies, literal, physics-permitted twins of this instant. By the end of tonight, you're going to understand that these three mechanisms rest on different assumptions, live in different equations, and have different levels of empirical support. But all of them emerge from the same serious toolkit scientists use to design spacecraft, model planets, and probe the deep structure of the cosmos. Now, let's begin to ask what they mean. If the universe is a block, or recurs or branches into countless copies, what happens to free will, to meaning, to that visceral sense that your life is unfolding for the very first time? That's the boundary we cross next. If the universe is a block, it sounds like the verdict is already in. Every heartbeat, every hesitation, every yes and no already etched into space-time like grooves in a record. From that perspective, it can feel as if you are not choosing at all. You're just reading a fixed script. In a block universe, past, present and future are equally real the way all locations in space exist at once in the solar system. Your birth, this exact moment and your last day are laid out together as one 4D structure. That picture seems to collide head-on with free will. If the whole timeline is there from the start, how could you ever have done otherwise? How could any choice be more than an illusion projected onto a frozen film? Before we get started on tearing that down, notice something. The no free will reaction quietly assumes that if events are fixed, then you must be dragged through them like a powerless passenger. But compatibilist philosophers and scientists argue that this is the wrong comparison. They say free will can coexist with determinism because what matters is not metaphysical wiggle room outside the system, but what happens inside it, your reasons, your character, your deliberation. Think of a novel. The ending is fixed the moment the author finishes the last page. No one expects the detective in Chapter 3 to literally alter the ink in Chapter 20. Yet inside the story, the detective weighs clues, doubts suspects, makes a risky call. Those decisions are real at the level of the narrative. They flow from who that character is, from motives and evidence that have been carefully set up. On the block universe view, your life may be similar. The entire book of space-time exists, but within it, you are a process. Neurons fire, memories surface, quantum events decohere, and you run through scenarios in your head. Your choice to turn left instead of right is not outside the block. It is a pattern inside the block, just as the solar wind is a pattern in space rather than something beyond it. From your internal perspective, you never see the later pages. You stand at the moving boundary of now with limited information and finite time. Your uncertainty is not fake. It is a real physical condition of a brain that has not yet interacted with those parts of space-time. When you deliberate, that neural computation helps determine what happens next along your world line. The fact that the outcome is already there in the 4D geometry does not erase the causal role of your thinking any more than a completed novel erases the logic of its own plot. Now, connect this back to repetition. Even if this moment is one fixed page in a cosmic book, even if in some quantum sense this configuration of atoms reappears in cycles or across branches, your experience of choosing inside it is not negated by its fixedness. It is the way this page is written. Tonight, we're going to push this further. If the script is set, why does it sometimes feel like you have already read it before? And what happens when quantum physics says the pages might overlap? Now, let's begin. Before we get started on overlapping pages and repeating scenes, pause the forward rush for a moment. Tonight, we're going to do something strange. Not run along your timeline, but step outside it. Imagine your entire life as a single glowing thread in space. Not just in ordinary space, but woven into the space-time of a block universe. From the first breath to the last heartbeat, it traces a continuous curve through the cosmic system, looping around planets, cities, rooms, and screens as the years unfold. To you, it feels like motion. To an outside mathematician looking at space-time as a whole, it is already there, completed, like a line of light etched into a crystal. Now, thicken that thread. Let it swell until it is not a line, but a sculpture. Every posture your body ever takes becomes a shape. Every heartbeat is a tiny twist. Every pattern of neurons that encodes a thought, a memory, a surge of fear or joy, becomes a delicate filament braided into the whole. The time dimension is no longer something you move through. It is the axis along which this sculpture extends. Zoom out mentally. Farther, farther still. At first, you only see this current second, like a razor-thin cross-section cut through the statue. Then the view widens. Minutes lock into place, then days, then decades. Birth, childhood, late-night screens, last conversations, all sit there simultaneously in a single 4D artwork. From this vantage, there is no before or after inside the sculpture. There is only structure. Here is the pattern interrupt. The everyday assumption is that you are a point sliding along a line, that the past is gone and the future does not yet exist. But in the block universe suggested by relativity, past, present, and future coexist as different coordinates in space-time. Already lived and not yet lived lose their usual meaning. All moments simply are. Your awareness becomes like a narrow spotlight sweeping along the sculpture, illuminating one slice at a time. No one expects this spotlight to have the same status as the sculpture itself. No one predicts that the feeling of flow could be a local illusion generated by a brain whose physical states are just static ridges in that 4D form. And absolutely no one anticipates how directly this picture speaks to the fear of repetition. Because if every point on the sculpture is equally real, the question, "Is this the first time?" starts to dissolve. The value of a moment may not come from its uniqueness, but from its intrinsic texture, the exact pattern of sensation, thought, and meaning encoded in that region of the sculpture. A quiet afternoon can be as significant as a once-in-a-lifetime event, not because it never repeats, but because of the way it exists in the whole design. From this view, even if quantum physics allows configurations to recur, what matters is the detailed geometry of experience, not the novelty stamp on its surface. In the next section, this static sculpture will meet the restless probabilities of the quantum wave, and the spotlight will start to flicker. Now, let's begin with the version of this idea that does not hide in equations. It walks straight at you. Nietzsche's thought experiment of eternal recurrence asks you to imagine a demon whispering that every second of your life will return, in exactly the same order, infinitely many times. Every hesitation, every regret, every quiet victory, no edits, no alternate takes. Is that a blessing or a curse? On the surface, it feels like a cosmic trap. If the universe is a frozen block of space-time and quantum evolution is just the same wave function cycling through configurations, then perhaps you are not moving through the solar system of your life at all. The whole orbit is already there, repeated across an endless mathematical sky. From the outside, it looks like a loop. From the inside, it feels like a journey. Tonight, we're going to connect that stark philosophical picture to the strange recurrences hiding in physics. Poincaré's theorem says that a finite, isolated system evolving under deterministic rules will, given enough time, return arbitrarily close to its initial state. Quantum mechanics adds its own twist. In a finite Hilbert space, the wave function can quasi-repeat, like an incredibly slow cosmic echo. No one predicts meaning from this. The equations do not care about purpose or guilt or joy, but they accidentally rhyme with some of the deepest existential questions ever asked. Here is the worry that often follows. If every choice you make is just one point on a track that loops, if some distant recurrence will replay this moment with the same words and the same heartbeat, does that drain the importance out of what you do now? And if many worlds is correct, with branching universes where copies of you choose differently, does the existence of those parallel decisions make this decision feel thinner, like one frame in a vast film reel of alternatives? Notice the contrast between the God's eye view and your own. From a hypothetical outside perspective, the quantum state of the universe might cycle or branch or tile an enormous configuration space. From your perspective, inside this particular branch, there is no copy, no loop, no rewind button. There is only this experienced sequence, this narrow corridor through the 4D structure. The pain you cause still hurts. The kindness you offer still lands. Their ethical and emotional weight is not diluted by echoes you never feel. By the end of tonight, you're going to understand that recurrence does not erase responsibility. It can intensify it. If this configuration really does return, or if infinitely many near twins exist somewhere beyond your horizon, then every pattern you establish in consciousness is, in a sense, etched deeper into reality. No one expects an endless loop to be comforting, but it can be clarifying. Here is the reframing. Eternal recurrence, read through quantum physics, can be treated as a demand, not a doom. Live in a way you would be willing to endorse if this exact trajectory were inscribed forever into the fabric of spacetime, or replayed on an infinite cosmic screen. Absolutely no one anticipates that a cold theorem about state spaces and recurrence times will turn into an ethical spotlight. Yet that is what it becomes when the abstract wave function meets a conscious observer. In the next section, that observer will step even closer to the quantum boundary, and the question will sharpen. What, exactly, is doing the experiencing when the universe evolves as a single, unbroken wave? The observer steps closer to the quantum boundary, and a new anxiety appears. If the universe is a single, unbroken wave, and if that wave branches into countless versions of events, then a blunt question follows. If every possible outcome happens somewhere, why should this one matter? This is the common reaction to the many worlds picture. The logic feels ruthless. In one branch, you keep a promise. In another, you break it. In one, you steer a spacecraft safely. In another, you cause a mission-ending failure. If all of those branches exist in the grand quantum state, does personal responsibility evaporate into the background noise of the multiverse? Before we get started, it helps to slow down and zoom in on a single branch. From the outside, theorists talk about a huge wave function spreading across configuration space, like the solar wind spreading through the heliosphere. From the inside, though, an observer only ever inhabits one thin stream of events. You never wake up in the branch where a different version of you chose differently. You never feel their regret or enjoy their triumph. This is the first crucial point. Many worlds is not a license to outsource consequences to distant copies. Those other histories are dynamically isolated, the way regions beyond the heliopause are cut off from the direct push of the solar wind. Once decoherence has done its work, branches no longer interfere. No signal, no influence, no way to reach across and say, "You handle the hard choice. This version will coast." Within your branch, your decisions still shape the local future. They determine whether trust grows or collapses, whether harm spreads or is contained, whether a community thrives or fragments. The people around you in this quantum slice are not less real because equations say there are other slices. Their pain is not discounted by the existence of a branch where things went better. Some physicists go further and talk about measure or weighting in the universal wave function. Not every branch may carry the same thickness in the quantum state. In that view, actions that reliably steer outcomes toward wide regions of configuration space with flourishing, low-suffering histories could, in principle, increase the total measure of good experiences. The numbers are abstract, but the ethical intuition is sharp. Choices can influence not just what happens, but how much of the universal amplitude is occupied by better worlds. Tonight, we're going to treat this as more than philosophy. By the end of tonight, you're going to understand why many worlds does not excuse apathy. It only changes the backdrop. You still ride one continuous stream of consciousness through one effective branch. You still stand at a boundary where options fan out like trajectories of spacecraft leaving the inner system. No one expects a cold, deterministic wave equation to restore urgency to everyday choices. No one predicts that thinking about branch weights will make a broken promise feel heavier. Yet that is what emerges when responsibility is viewed against a sky full of parallel timelines. Now, let's begin to press on the deeper question hiding underneath. If there are countless versions of you, what exactly makes this one you? And what happens to that sense of identity as the branches keep multiplying? That question hides an even stranger possibility. What if this version of you is not actually moving anywhere at all? In both relativity and quantum mechanics, there is no built-in conveyor belt of time dragging you from past to future. The equations do not show a cosmic clock hand sweeping across the solar system. They show static relationships, reversible dynamics, a four-dimensional space-time where every event simply exists. In Einstein's block universe, your birth, this moment, and your last breath all occupy their own coordinates, like planets already pinned in a map of space. From that perspective, the flow you feel is not in the universe. It is in the observer. Neuroscientists discovered that conscious awareness actually lags behind physical events by tens or even hundreds of milliseconds. A sound reaches the ear, light hits the eye, the body reacts, and only after that does the brain assemble a narrative that feels like a continuous now. Signals from different senses arrive at different times, yet are stitched together into a single moment. This temporal binding is not passive reception, it is active construction. So the brain edits, it backdates experiences, it smooths over gaps, it turns discrete neural events into what feels like a flowing movie. No one expects this inner editor when thinking about time. No one predicts that what feels immediate is already slightly in the past by the time it becomes conscious. Psychologists call the result the specious present. A short window, maybe a few hundred milliseconds long, that the brain treats as a single, thick now. Within that window, the beginning, middle, and end of a motion, a word, even a musical note are blended. You never perceive an infinitesimal instant. You perceive a packet, a tiny segment of your personal timeline compressed into a single experience of presence. That raises a sharp question. If physics offers a block universe and the brain offers only these stitched packets, is the feeling of moving from one moment to the next less like a measurement and more like a user interface? A kind of evolved dashboard, optimized to track threats and opportunities in space, not to reveal the raw structure of time in the system itself. Tonight, we're going to treat that interface as seriously as any spacecraft instrument. Because if the universe is a static 4D mission log, and consciousness is reading it frame by frame, then the sense that each frame happens once, then vanishes, may be an illusion. By the end of tonight, you're going to understand how that illusion could still feel overwhelmingly real, even in a block universe filled with quantum branches, recurrences, and timelines that loop back arbitrarily close to where they started. The next step is to ask how a brain locked into a specious present would experience a cosmos where, from the outside, nothing truly flows at all. From the inside, your consciousness feels like a film strip moving forward, frame after frame, moment after moment. But if the block universe is a frozen reel, something else has to be deciding which direction you experience those frames in. Now, let's begin with a quiet villain hiding in plain sight: entropy. In thermodynamics, entropy is not just disorder. It is a precise count of how many microscopic arrangements of particles correspond to the same large-scale state. One neat ice cube in a glass has far fewer possible micro-configurations than the same water melted and mixed into the air. That's why in this cosmic mission through time, entropy tends to increase. The thermodynamic arrow of time is the direction from low entropy to high, and here's the pattern interrupt. That same direction is where your memories point. You remember a lower entropy past and anticipate a higher entropy future. Eggs crack, cream mixes into coffee, the solar wind blows outward and spreads, never spontaneously reassembling into a pristine, untouched system. Your brain encodes traces of earlier, more ordered states, so psychological time quietly locks onto the same arrow that governs heat, diffusion, and decay. But why is there an arrow at all if the deep laws seem to allow time to run both ways? At the level of fundamental equations, most of physics is time-symmetric. Reverse the motion of every particle, and the equations still work. No one expects an electron to care which way time flows. No one predicts Maxwell's equations or the Schrödinger equation will suddenly break if the film is played backwards. The asymmetry does not come from the rules. It comes from the boundary conditions. According to the low entropy past hypothesis, the entire observable universe began in an extraordinarily ordered state, far smoother, far more uniform, far less entropic than it had any right to be by random chance. From that improbable beginning, there is an immense gradient for entropy to climb, and along that gradient complexity can form: galaxies, planets, chemistry, life, and memory-bearing brains that can track what used to be, but not what will be. Tonight, we're going to treat your sense of uniqueness as a thermodynamic side effect. Each now feels new because each now sits further along that entropy slope, with slightly more information irreversibly recorded in your neurons and in the environment. When a measurement is made, when a choice is logged, microscopic details disperse into countless degrees of freedom, making the past hard to erase and the future open. Now connect this to recurrence. In a finite block universe, given enough time, a vast region of high entropy can fluctuate into a rare pocket of low entropy that perfectly matches this moment. In that pocket, your body, your room, your memories would all be reconstructed down to the last quantum detail. From the outside, it's a repeat. From the inside, it is simply now again, with no tag saying second run. And absolutely no one anticipates what that does to the idea of living only once, because the real shock comes when quantum theory is added to this thermodynamic arrow, and the boundary between one timeline and many starts to blur. Now, let's begin a different kind of experiment. Before we get started with quantum equations and branching timelines, pause and flip a single assumption. Not about space, not about the solar system, but about your own mind. Imagine a world where brains work almost exactly like yours, obeying the same physics, the same rising entropy, the same thermodynamic arrow. One change only. Those brains form memories of future states instead of past ones. In that world, a person wakes up already remembering next week. The conversations, the decisions, the way the wind feels on a day that, from your perspective, has not happened yet. They feel pulled toward that remembered future, the way you feel pulled toward your remembered childhood. It is familiar. It is already lived. What surprises them is not what comes next, but what came before. Their own past blindsides them. A glass shatters on the floor. For you, the shock is in the break itself, because you remembered the intact glass and not the moment of impact. For them, the shock is the intact glass that existed a few seconds ago, a state they did not remember and could not have predicted. The shards on the floor, perfectly expected, already in memory, already filed under what has happened. Notice what has not changed. The glass still goes from whole to broken. Entropy in their kitchen still increases. The equations scientists use to describe the motion of every particle in that room are identical. From an external perspective, the entire physical history of that world could be a perfect copy of ours. The same boundary conditions, the same expansion of space, the same evolution of planets and spacecraft and missions that reach beyond their star. Only the direction of the memory arrow is different. From the inside, though, that single flip rewrites the meaning of time. For them, the already lived region lies ahead along the physical timeline, and the not yet lived region lies behind. The emotional weight of nostalgia points toward what you would call the future. Regret attaches to events you have not yet seen occur. By the end of tonight, you're going to understand that nothing in the fundamental structure of time had to change to make this happen. Only the way brains encode information. This is the pattern interrupt. No one expects that the feeling of moving from past to future might be a local cognitive habit, not a cosmic law. No one predicts how fragile the sense of now becomes once memory orientation is negotiable. Now, bring recurrence back into the frame. In a universe that can, over vast spans, reconstruct your present brain down to the last quantum detail, a future recurrence of you does not feel like a replay. That future brain carries this moment as past, not as a second run. From the outside, the system repeats. From the inside, there is only a continuous thread of remembered events, each now believing it has never been here before. And absolutely no one anticipates what happens when quantum theory suggests those threads may weave through a space-time where every version of you already exists. So, it is time to ask a harder question. When physics hints that every version of you already exists, What does it actually guarantee about reliving this moment? And what does it very carefully stop short of saying? Before we get started, anchor the solid ground. In relativity, the block universe is not a wild metaphysical leap. It is a natural reading of Einstein's equations. Space and time fuse into a four-dimensional spacetime, where the solar system is not a movie playing frame by frame, but a complete film reel laid out at once. Every event launches memories. Even this sentence has coordinates in that block. Past, present, and future are just different locations. In classical mechanics, Poincare recurrence is equally rigorous. Take a finite, isolated system with fixed energy, evolving under deterministic laws. Given a long enough time, the theorem says the system's state will return arbitrarily close to where it started. Not by magic, but because there are only so many ways to arrange its energy. In quantum theory, similar recurrence shows up when a bound quantum system's wave function evolves and later reconstructs its original pattern. Then there is many worlds. No one predicts wave function collapse in that interpretation. Instead, the wave function of the universe evolves smoothly, and every quantum outcome is realized in a branching structure of histories. It is a clean, mathematically consistent way to read the same equations that guide real spacecraft and real detectors. So far, so dramatic. But here is the pattern interrupt. None of these frameworks has been experimentally proven to imply that you, as a conscious observer, will re-experience this exact moment in a way you could distinguish from its first run. The block universe can contain this scene once. Recurrence can bring a system's configuration arbitrarily close, but not necessarily with the same world beyond its boundary. Many worlds can host versions of you on neighboring branches that remember nearly identical pasts. From the outside, those look like replays. From the inside, each thread is just a single unbroken mission from birth to death. Talk of you hopping between branches or waking up again in a far future recurrence quietly smuggles in assumptions about what personal identity is and how continuity works that physics alone does not settle. This is where misconceptions rush in. There is no evidence for consciousness jumping between quantum branches like a spacecraft changing planets. No known mechanism lets memories leak across Poincare recurrences, so a future brain arranged like yours would not remember earlier cycles as cycles. Déjà vu feels uncanny, but experiments do not support it as a quantum echo. Neuroscientists discovered far more mundane explanations in how the brain encodes and mistimes experience. By the end of tonight, you're going to understand the responsible takeaway. It is not science proves reincarnation of moments. It is that our best theories make the apparent uniqueness and linear flow of experience less obvious than they feel. The universe may be a block. Quantum histories may branch, states may recur. But what it means for a conscious self to relive a moment is a deeper question, and in the next section, the focus turns to what that might imply for how you navigate the one life you actually remember. So now the question becomes unavoidable. If the universe may be a block, if quantum histories may branch and recur, then what exactly is this you that seems to move through time only once? Tonight, we're going to lay out 3 different ways to think about that question, 3 different models of self that can survive in a quantum, block-like cosmos. Perspective 1, the narrative self. In this view, you are the story your brain tells, a continuous thread stitched from memories, expectations, and sensations. The block spacetime is like a complete film reel already containing every frame. Your conscious life is the experience of those frames being played in order along one path, meaning here does not come from the reel being unique. It comes from the coherence of the plot. A novel is not less powerful because other novels exist, or because the pages could, in principle, be reprinted. In a universe where states may recur, the narrative self treats repetition the way a reader treats a reread. The same events, the same lines can still matter because the lived experience inside the story is fresh from the character's point of view. No one expects a character on page 200 to be depressed that page 200 has been printed before. The value is internal to the arc, not external to its cosmic rarity. Perspective 2. The pattern self. Here, you are not a particular chunk of matter, but an informational pattern implemented in that matter. If the same detailed pattern of neural firing and structure appears twice, separated by time, space, or even different quantum branches, the argument is that the same self is instantiated twice. Scientists talk about quantum states evolving according to the Schrödinger equation, about the wave functions spreading across many possibilities. The pattern view says, what matters for identity is the structure within that wave, not the coordinates on a map. In this frame, a recurring or coexisting moment is not a ghostly copy. It is another realization of the same pattern, like the same software running on different hardware. That can be unsettling. It can also be liberating. Your responsibility attaches to the pattern of choices and responses, not to a single, fragile token of matter drifting through the solar system. Perspective 3. The relational self. Now, you are defined by the network of relationships and interactions anchoring a particular branch or region. The people remembered, the signals exchanged, the causal links that actually form a web around this body, in this history. In a many worlds picture, there may be countless branches where similar patterns appear. But this view says what makes you this, you is the local context. Who can be called, who can be helped, which consequences propagate outward from this moment. Each perspective digests repetition differently. The narrative self says, even if the film exists all at once, the story still unfolds from within. The pattern self says, even if the pattern runs more than once, the integrity of the code still matters. The relational self says, even if there are other branches, the boundary of care is drawn by real connections here. None of these require magical thinking about quantum time. None of them force nihilism. They are tools, frames, ways to understand how a block universe, branching histories, or rare recurrences might coexist with meaning. By the end of tonight, you're going to understand how to choose a perspective that preserves wonder and responsibility, even if this moment is not one of a kind. Now, let's begin the synthesis and see what survives when all three models are pushed to their limits. Now, let's begin. To redefine already lived, the first move is to stop thinking of time as a river and start thinking of it as space. Not metaphorical space, actual space-time. In a block universe, your life is not a line being drawn in real time. It is an entire track already laid down in the 4D structure of the cosmos. Past, present, and future are like different cities on a solar system map, separated by distance, not by existence. That means already lived does not mean gone. It means located elsewhere. The moment when a childhood memory formed, the moment when a future mission succeeds or fails, and this exact moment right now are all coordinates in spacetime. Scientists picture them as points along your world line, the path your body traces through the universe. Just as Voyager's position at Jupiter is as real as its position beyond the heliopause, your 10th birthday is as real as your final day. All of them coexist in the block. So when the mind says, "That's over," the block universe quietly disagrees. The event is not erased. It is pinned permanently at its own address in space-time. In that sense, every moment of your life is eternally being lived by the version of you that occupies that coordinate. The you who first saw Saturn's rings through a telescope is still there, forever looking up. The you who will one day watch the solar wind fade in a sunset is already there, forever watching. What changes is not which moments exist. What changes is the index of conscious awareness sliding along the world line. The brain generates a moving now, like a spotlight, scanning across film frames that are all equally present. No one expects the frame behind the light to vanish. No one predicts the frame ahead to be less real. The only thing that shifts is which slice of the block gets illuminated as this moment. You never literally go back, but the moments you remember do not fall off the edge of reality. This view can soften the fear of transience. If the universe is a fixed 4D structure, then the first time a hand was held, the last time a voice was heard, the instant a difficult choice was made, none of these are fleeting sparks that disappeared into nothing. They are woven into the geometry of space-time as enduring features like mountains in a landscape the solar wind can blow across, but never erase. So under eternalism, saying you have already lived this moment becomes less a claim about repetition and more a claim about status. This moment is one of many eternally real facets of your world line, as solid in the block as any other. Tonight, we're going to push this even further. What happens when quantum branching and recurrence are layered on top of a frozen block where every version of you is already there, waiting? In that frozen block, every version of you is already there. But recurrence adds a new twist, not just coexistence, but return. In finite systems, configurations don't just exist once. Under the right conditions, they can come back. Not in a neat, cinematic loop, in a slow, almost unimaginable drift through state space where patterns reappear the way constellations might reassemble after trillions of shuffled skies. Mathematically, this is what recurrence theorems say. Take a closed, finite system obeying deterministic laws. Let it evolve long enough. The theorem guarantees that, after a vast but finite time, the system will return arbitrarily close to its starting configuration. The timescales are absurd. For something as complex as a human brain plus environment, the recurrence time dwarfs the age of the observable universe. Human history? A flicker. Every civilization that has ever risen and fallen would be less than a rounding error on that clock. Now zoom out from you to the entire cosmic stage. Some cosmological models suggest the universe itself might cycle. A bouncing universe that contracts, hits a minimum, then expands again. Ekpyrotic scenarios where our three-dimensional world is a brain colliding, separating, and colliding again in a higher dimensional space. There are models where the solar system, the planets, every mission, every spacecraft could, in principle, have distant analogues in previous or future cycles. No one predicts that any specific model is confirmed yet. Scientists are still testing, still arguing, still listening for clues in the cosmic microwave background and the distribution of galaxies. Pattern interrupt. This is not about destiny. It's about scale. Whether the cosmos bounces or not, whether quantum recurrence ever has time to complete a lap, your particular life is a microscopic pattern in this enormous exploration of possibility. The boundary between once and many times is almost meaningless compared to the gulf between your few decades and cosmic time. But that gulf does not drain meaning. It frames it. Think of your life as a local configuration of the universe, a specific alignment of atoms, memories, hopes. If recurrence occurs, that configuration might arise again, somewhere in phase space, or in some later cosmic cycle. From the inside, that recurrence is not a faded echo. It is a fresh, first-person present. By the end of tonight, you're going to understand that the universe has no label for rerun versus premiere. Each instance is as vivid, as immediate as any other, because now is always defined from within. So what does that do to value? If this moment has infinitely many cousins scattered across cycles, it does not become cheaper the way mass-produced objects feel less special. The opposite happens. The universe is spending extraordinary effort, enormous time, enormous volume of state space to realize this delicate pattern at all. No one expects a finite system to explore its possibilities so extravagantly. No one anticipates how that extravagance can feel intimate. Now, let's begin to push this to its limit. What if, instead of waiting for cycles, quantum branching is already giving your moment countless parallel siblings, all existing side by side? Quantum theory's most radical move is to treat that question as literal. In the many worlds picture, the wave function of the universe never chooses a single outcome. It unfurls. Every quantum event is not a coin landing heads or tails. It is a branching, a split in the mathematical description where both outcomes continue, each carrying its own version of the solar system, the planets, and you. Tonight, we're going to stand inside that branching. Imagine every interaction of particles in your brain, every photon scattering off the walls of your room as a tiny fork in a cosmic tree. The result is not one clean timeline, but an expanding forest of histories, each one a complete, self-consistent world. Many contain near-identical versions of your life, with the same childhood, the same memories, the same sense that this moment is happening only once. But from your internal viewpoint, there is no forest. There is a path. Conscious experience threads through one branch of the wave function, not because the other branches vanish, but because decoherence seals them off, like parallel trails hidden by thick fog. Your memories are the record of the path already walked. Your expectations are the map you sketch for the next few steps. Together, they define a single sequence, a single mission through possibility space. Before we get started on what that means for déjà vu and repetition, anchor it with a simpler picture, a dense forest crisscrossed by countless trails, some loop back, some climb, some dead end at a cliff. From above, the pattern is obvious. There is not one privileged route. But when your boots are on the ground, the only path that matters is the one under your feet. You feel the slope in your legs, you hear the wind in these particular trees. The existence of other trails does not dilute the reality of your walk. It does not make your scraped knee less painful, or your shared conversation at a clearing less real, just because there were 1,000 other ways you could have moved through the same terrain. In the same way, the presence of other branches in the quantum multiverse does not make this branch a copy or a discount version. It is as real as any other, because reality in this framework is the entire branching structure, and your life is the route traced within it. By the end of tonight, you're going to understand a subtle point. Other branches are not competitors for meaning, they are neighbors. Their existence no more threatens the significance of your experiences than the existence of other people threatens the significance of your own memories. No one predicts that adding more conscious observers to space makes consciousness less important. Adding more branches does not either. Now, let's begin to merge this with the block universe idea. In relativity, space-time is a four-dimensional landscape where past, present, and future coexist. Many worlds turns that single landscape into an immense branching canyon system, with each fork representing a quantum decision point. Your path is a single carved line on one canyon wall. It is not the only line, but it is uniquely yours. So even if the underlying reality is richer and stranger than a single timeline, you can treat your lived moments as singular. This instant, with its particular pattern of neurons, its particular view of the world, will never be repeated in your branch. The multiverse may recycle configurations, quantum recurrence may echo similar scenes somewhere else in the grand system. But the way you arrive here, the sequence of choices, accidents, and quantum flickers that delivered you to this frame of experience, is one of a kind. In a sense, many worlds does for time what Voyager did for the edge of the solar system. It reveals that what seemed like a simple boundary is actually a complex, structured region full of unexpected channels and flows. No one expects the familiar feeling of now to be underwritten by such an extravagant architecture. Yet here you are on one branch, looking out. The question then is not whether there are other versions of this moment somewhere in the branching forest. The question is why this particular path feels so continuous, so inevitable, so much like the only way things could have gone. To answer that, the next step is to zoom in on the observer, the role consciousness plays in stitching a single flowing story out of a frozen, branching space-time. So, what actually changes if this moment isn't unique, if, in the vast architecture of space-time, something like this scene has unfolded before and will unfold again? The first thing to wobble is the sense of being cosmically singular, the feeling that this exact configuration of matter, this tiny corner of the solar system, is a one-time only event, written once and then erased forever. In a block universe picture, the whole 4D structure already exists. Every frame of your life, every branch the quantum wave function could explore is part of a frozen mission profile etched into space-time. In recurrence ideas, a finite system can, given enough time, return arbitrarily close to where it started. No one expects everyday consciousness to be thinking about Poincaré theorems while doing the dishes, but the implication is stark. The boundary between once and again is not as solid as intuition suggests. Your sense of time's flow shifts too. Instead of a single arrow slicing cleanly from past to future, the mind starts to imagine a layered trajectory, a path through a landscape that already exists, or one branch among countless, equally real branches. The assumption of a single, unrepeatable life path gives way to something stranger. There may be other routes through the same global structure, other versions of you feeling that same inevitability along different tracks. But notice what does not move, even if the cosmic story loops or branches. The immediacy of joy and pain remains. A heartbreak still hurts. A quiet moment of awe at the night sky or at a spacecraft slipping beyond the heliopause still feels like a revelation. The reality of relationships does not dilute because the wave function has other terms. When someone is kind, that kindness lands in one experienced stream of moments. When someone is cruel, the ethical weight of that choice is not averaged out over parallel planets. By the end of tonight, you're going to understand that from the inside, you only ever ride one continuous sequence of experiences. Whatever quantum mechanics says about branching, whatever relativity says about a static spacetime, the observer only encounters one unfolding narrative. That narrative is where responsibility lives. Whether or not this moment recurs elsewhere or elsewhen, the obligation to respond well, to tell the truth, to help where possible, to pay attention, does not vanish. It intensifies because this first-person window is all that is directly given. Seen that way, non-unique moments do not trivialize life. They amplify humility and wonder. You are a local pattern of matter in a much larger system, shaped by quantum fields and solar wind and galactic motion, briefly becoming aware of the deep structure that produced you. Tonight, we're going to treat that not as a downgrade, but as an astonishment, tiny, yet capable of reflecting on time itself. Insignificant on a cosmic scale, yet somehow able to ask whether this instant has already been lived. Before we get started on consciousness itself, on how an observer stitches a flowing now out of this frozen, branching reality, we need to confront one more disturbing possibility hidden in the equations. Here's the quietly radical thought to carry out of this. Physics is telling you, in multiple independent ways, that your sense of time as a one-way, one-time stream is not the whole story. Not an illusion, but not the full architecture either. The same way Voyager found the solar wind didn't just fade into nothing, but hit a hidden boundary and transformed, your experience of now may be brushing against deeper structure. Relativity's block universe says every event in your life already sits inside spacetime, like cities along a fixed highway. Quantum mechanics adds that between those events, reality flows as a wave of possibilities, not as a single, fragile line. And in finite systems, the Poincaré recurrence theorem whispers something even stranger. Given enough time, configurations repeat. Not just similar, arbitrarily close. A pattern, once realized, is not condemned to happen only once. So, here is the shift. Tonight, we're going to trade the picture of your life as a delicate thread that might have been otherwise for something more unsettling and more stable. Your life becomes one realized pattern in a vast space of possible patterns, one trajectory among many in a cosmic phase space. In some interpretations, many worlds branching, cyclic cosmologies, or recurrent quantum states, that pattern can, in principle, be instantiated more than once, in more than one region of space, more than one era of the universe. No one predicts this will feel comfortable at first. If meaning has always been tied to being cosmically unique, then the idea that your exact configuration could appear again can feel like an existential downgrade, a demotion from once ever to one of many. But there is another way to read the same equations. If value comes from depth of experience rather than from scarcity, then repetition is not an insult. It is a kind of emphasis. Right now, look around, the chair beneath you, the faint hum of a fan or the distant wind outside, the soft glow of the screen, the particular mix of memories and expectations hanging in your mind at this instant. By the end of tonight, you're going to understand that. In several serious physical models, this entire configuration is not a temporary accident that vanishes without a trace. It is etched into the fabric of the universe's state space. a point in the grand system's trajectory that, under the right conditions, can be revisited. No one expects a quiet room to be a frontier of cosmology. Yet here you are, sitting at a boundary between classical intuition and quantum relativistic time. The mission from here is not to prove that you have already lived this moment before, but to recognize that the question itself now has a more nuanced, defensible answer. Now, let's begin that last leg. To understand whether this you, in this instant, can repeat, we have to talk about the one thing every equation has been quietly depending on, an observer. The observer was the final boundary in the equations. Now, the mission turns around. Just as Voyager left the solar system and then looked back, you get to step outside your own timeline for a moment and look at it from the edge. Tonight, we're going to line up what you've seen. A grand tour, not of planets, but of possible times. From the block universe where past, present and future coexist in a four-dimensional structure, to quantum branches where the wave function never really collapses, to recurrence theorems that whisper, given enough duration, patterns return. Designed to feel like a single fragile instant, this moment feels unique. The reality you've just explored says, maybe not. In a block universe, every event in your life already occupies its coordinates in spacetime, the way each world Voyager passed already sat in its orbit in the solar system. No one predicts the present in that picture. It just is, alongside every other slice. Then quantum mechanics pushed you beyond that calm, frozen landscape. A system evolves smoothly under the Schrödinger equation until an observation forces a definite outcome. Some scientists say the wave function truly collapses. Others in many worlds say all outcomes happen, branching the mission into parallel timelines where different yous watch different versions of this same video. Pattern interrupt. Pause and look around the room. The chair. The screen, the quiet hum, or distant wind. Under one interpretation, there are countless branches in which this scene is almost, but not quite, the same. An object moved, a thought different, a notification arriving a fraction of a second earlier. Then came recurrence. In a finite, isolated system, Poincaré showed that states can recur arbitrarily close to where they started. Combine that with quantum indeterminacy, and one picture of the cosmos looks less like a straight line and more like a vast, folding map where configurations repeat across unimaginable distances and times. No one expects eternal novelty. No one predicts an endless supply of completely new arrangements. In some models, absolutely no one anticipates an escape from repetition. By the end of tonight, you're going to understand something subtle. You now hold several scientifically grounded ways in which this moment might not be unique. A block universe where it always exists, quantum branches where it has near twins, and recurrent scenarios where it, or something indistinguishably close, returns. You also know the caveats, the open questions, and the philosophical stakes. And yet, in a universe where time may be a landscape and moments may recur, the fact that you are here, now, aware and curious, is its own small miracle. Out of all the possible configurations of matter and quantum fields, this conscious snapshot organized itself. Like a lone spacecraft crossing the heliopause, your awareness has slipped beyond automatic habit into reflection. So carry this with you. When you stand in line, when sunlight hits a window, when a quiet evening feels ordinary, remember, each instant is an intersection of deep physical laws and a fragile, transient observer. Before we get started on the next question, this is the message Voyager sends from the edge of space and your own timeline alike. The universe may repeat, but this act of noticing is never trivial. Before we get started on closing this journey, notice something simple and astonishing. You are still here. Nearly 2 hours of quantum time, identity, and déjà vu, and you stayed. That already tells scientists something about you. Most people bounce off the surface of these questions. They hear block universe or many worlds and tap out. You stayed through wave functions, recurrence theorems, and branching timelines. That means you are part of a rare mission profile in this solar system of attention. The long-duration explorers, the ones willing to cross the boundary between quick explanations and deep uncertainty. So this is an invitation, but not a generic one. If this kind of long-form dive into the strange structure of reality feels like home, subscribe, hit like. Share this with the one friend who stares out of bus windows and wonders whether this moment has already happened. To the algorithm, those are just signals. To this channel, they are telemetry from a small, scattered crew that wants more than highlights, designed for short clips and hot takes. That is the default state of the platform, but you are proving a different trajectory is possible. When you subscribe and turn on notifications, you are telling the system that there is an audience for slow, careful voyages through quantum time, not just quick flybys. No one expects that to matter. No one predicts a single click can change the kinds of videos the algorithm launches. And absolutely no one anticipates how far a small, persistent signal can travel. Tonight, we're going to treat this video as one leg of a longer mission. Next, the plan is to follow the arrow of time itself, why entropy gives time a direction when the microscopic equations do not. After that, the path leads toward black hole information and how a collapsing star might scramble, hide, or preserve the data that makes a person. Beyond that, lies the quantum origin of space-time, how the geometry of space could emerge from entanglement, the same quantum wind that shaped this entire discussion. By the end of tonight, you're going to understand this channel as a kind of theoretical Voyager, modest hardware, long missions, pushing past the familiar planets of everyday explanations into the dark where new ideas wait. Now, let's begin a different kind of experiment together. Leave one specific trace in the comments. Which of the three mechanisms, block universe, recurrence, or many worlds, most changed how you think about your own life, and why? That single sentence is a measurement, a data point in how human observers respond when the universe hints that time might loop, branch, or already be complete. Until next time, keep looking up, and maybe, just maybe, remember that somewhere in the vastness of possibility, another version of you is doing the same. So, here is one last question to smuggle out past the credits with you. If you ever come back and replay this video, are you reliving this same moment of understanding, or creating a new one that only looks like it from far away? On one level, the answer feels simple. The digital file doesn't change. The pattern of bits sitting on some server or in your device's memory is the same pattern that streamed into your eyes and ears the first time. The same voice, the same sentences, the same animation of space and time and quantum diagrams. From the perspective of the file, the mission repeats exactly. Press play, and the signal launches again. But your brain is not a static archive. It is more like a turbulent solar wind, always moving, always interacting, never quite in the same state twice. The second time you cross this moment, your neurons fire along routes carved by the first viewing. Some connections are strengthened, some are pruned, some memories of your day leak in around the edges. The boundary between the same experience and a new one starts to blur, just as it did when scientists tried to define a sharp edge to the heliosphere and discovered a messy, layered transition instead. In a sense, this replay is a tiny Poincaré recurrence, not of the whole universe, but of a small pattern inside it. The same words, the same ideas, the same questions about repeated lives and looping timelines, all returning to a configuration that is familiar, but not perfectly identical. No one expects a YouTube video to be a laboratory for deep questions about identity over time. No one predicts that pressing play could echo the structure of a finite system revisiting its previous states. Yet every repetition in your life works this way, replaying a song that once meant everything. Walking again through a childhood neighborhood, reopening a memory that has already been edited by every prior recall. Each time the pattern is nearly the same, but the observer has drifted a little farther along their own trajectory through spacetime. Tonight, we're going to treat those tiny loops as local versions of the grand cosmic recurrences that quantum physics and relativity hint at. So, when déjà vu hits, standing in a doorway, hearing a phrase, watching this exact frame of this exact video, use it as a signal, a reminder that by the end of tonight, you're going to understand that again is never trivial. It is a point where patterns, probabilities, and memories line up just closely enough to feel like a repeat. Whether or not the universe literally makes you live this moment again, every replay from now on is a chance to notice how layered time really is. Before we get started with whatever comes after this video, carry that with you. Every time something in your life happens again, you have permission to see it as a small experiment in identity, a local test of what it means for a moment to return. And somewhere, beyond your screen, beyond the solar system, beyond the visible boundary of what you can imagine, there may be other versions of this same question, still waiting for you to press play.